Hi and Assalamualaikum. My name is NURUL alias SAFEYYAH binti AMINUDIN. I am from D1CDCS1434A. My matrix number is 2022878853.
Assalamualaikum. My name is LIEZDA binti ZALI from CDCS1434A. My numeric is 2022840996.
Assalamualaikum and hi. My name is FARAH WAHIDA binti JUSOH alias YUSOF. I am from CDCS1434A. My matrix number is 2022857014.
Case study 1. Introduction. In order to fully understand how supply and demand interact to determine the price and quantity of items in a market, economics theory concept of market equilibrium is essential. This case study attempts to investigate how the market equilibrium for products can be found by applying Cramer's rule, a mathematical approach for solving system of linear equations. Of case study 1. First, to identify equilibrium prices and quantities using the supply-demand and supply functions, determine the equilibrium prices and quantities. Second, to demonstrate application of Cramer's rule, highlight how Cramer's rule can be applied practically to address economics issues. Third, to improve knowledge of market dynamics, offer perspective on how interrelated markets affect quantity and price. Methodology case study 1 question 1. First, write down the equilibrium condition for each product. 1 for pens, 2 for paper. Hence, reduce two equations in P1 and P2. Second, use Cramer's rule to find the equilibrium prices and quantities for products. Solution for A, the equilibrium condition for each good is that QS equals to QD. For pens, we got 4P1 negative 4P2 equals to 36, and for paper, we got negative 3P1 plus 14P2 equal to 40. Solution for B, we need to applying Cramer's rule in this case. Then we got for P1 we got 50.09 and P2 6.09. Then we need to substitute these values of P1 and P2 into original equation, solve for Q1 and Q2. Then we got QD1 equals to 39.27 and QD2 equals to 69.09. Next, we move to methodology case study 1 question 2. First, write down the equilibrium condition for each good, hence deduce three equations in P1, P2 and P3. Use Cramer's rule to find the equilibrium prices and quantities for P1, P2 and solution for A. The equilibrium condition for each good is that QS equals to QD. For good P1, we got 10P1 minus 5P2 plus 3P3 equals to 55. For good P2, we got negative 7P1 plus 14P2 minus 5P3 equals to 27. For good P3, we got negative P1 minus 5P2 plus 7P3 equals to 18. As shown in the slide, we need to apply Cramer's rule. Then we got A 607, A1 4249, A2 5,463 and A3 we got 6,070. Next, we need to find P1, P2 and P3. For P1 we got 7, P2 we got 9 and P3 we got 10. Next, we need to substitute these values P1 equal to 7, P2 equals to 9 and P3 equals to 10 into original equations, solve for Q1, Q2 and Q3. For Q1, we got 51, for Q2, we got 103, and for Q3, we got 39. Result and discussion case study 1 question 1. The last methodology answer for question 1 says that P1 equals to 50.09 and P2 equals to 6.09. As a result, the equilibrium prices for pens is RM 39.27 and for paper is RM 69.09 respectively. And discussion case study 1 question 2. The last methodology answer for question 2 says that P1 equals to 7, P2 equals to 9 and P3 equals to 10. As a result, the equilibrium prices for each goods A equals to 51, B equals to 103 and C equals to 39 respectively.
Introduction for case study 2. In these cases, we need to calculate individual prices depending on the good entrance fee for children, teenagers, and adults based on the total fee paid by different group at an exhibition center. Next, we find bus, taxi, and van fares per person based on total fares collected by the transport company for various passenger combination. Finally, we calculate the prices of carry out donut and nugget using the total cost of different confectionery combination. Each problem involves solving a system of linear equation. In this case study, we use the Gaussian elimination method, the Gauss-Jordan elimination method, and the inverse matrix method. Purpose of study for case study 2. First is to find the entrance fee for a child, a teenager, and an adult by using the Gaussian elimination method. Second is to find the bus, taxi, and van fares for one person by using the Gauss-Jordan elimination method. And the last one is to find the price of a curry puff, a donut, and a nugget by using the inverse matrix method.
Next is methodology. For case study 2, question number 1. There are 6 steps in this question. First, to find values for the entrance fee for a child, a teenager, and an adult, we define children, teenagers, and adults with such variables. First, let children as X, let teenager as Y, and then let adult as Z. And step number 2, set up a system of linear equations based on the given information. First, for group A, 3x plus 2y plus z equals to 91. And for group B, we will get x plus 3y plus 2z equals to 114. And the equation for group C, 2x plus y plus 4z equals to 138. Step number 3, form an augmented matrix corresponding to the linear equations based on previous slide. So the form will be like below. Step number 4, use an elementary row operations on the augmented matrix until the row echelon matrix. So the last answer for ERO will be like below. Step number 5, convert the row echelon matrix to a corresponding system of linear equations. For equations number 1, we will get x plus 3y plus 2z equals to 114. For equation number 2, we will get y plus 5 over 7z equals to 251 over 7. And equation number 3, z equals to 25. And then, we solve this system by using back substitution as our last step. First, we substitute z equals to 25 into equation y plus 5 over 7 z equals to 251 over 7, and then we will get y equals to 18. And then we substitute z equals to 25 and y equals to 18 into equation x plus 3y plus 2z equals to 120. And then we will get the final answer for x, y, and z equals to 10, 18, and 25 respectively. Number 2. There are 5 steps in this question. First, to find values for the bus, taxi, and van fares for one person, we define bus, taxi, and van with such variables. First, let bus as x. Second, let taxi as y, and then let van as z. Step number 2, set up a system of linear equations based on the given information. For statement number 1, we will get x plus y plus z equals to 25. For statement number 2, x plus 2y plus 3z equals to 49. And the statement number 3 will be 2x plus y plus z equals to 32. Number 3, form an augmented matrix corresponding to the linear equations from previous slide. So the form will be like this. Step number 4, use an elementary row operations on the augmented matrix until the reduced row echelon matrix. So the last RO will be like below. The last step is find the solution to this system by converting the reduced row echelon matrix to a corresponding system of linear equations. Here we get a unique solution that is x equals to 7, y equals to 12, and z equals to 6.
The third step is to write the system in the form of 3x equals to 2, as you can see in the slide. fourth step, we need to use the inverse method to find the inverse. We need to use DRO and fill the left side with the matrix addition, as you can see in the slide. The last step is to solve the system by using the formula as equal to A inverse multiplied by B. As you can see in the slide, we use the x as x, y, z, and let's put to the right side of what we get before, the DRO and ALEEYA, which is 40 per 23, negative 11 per 23, and 2 per 23. And then the second column is negative 11 per 23, 7 per 23, and 5 per 23. And then the third column is 2 per 23, 5 per 23, and negative 3 per 23. And then we're gonna multiply by D, which is 2.8, 3.3, and 4.3. And then we're gonna solve it. And we're gonna get 0.5 for x, y is 0.6, and z is 0.4.
Next is result and discussion. First for result. Question number 1. The last methodology answer for question 1 states that x equals to 10, y equals to 18, and also z equals to 25. As a result, the entrance fees to an exhibition center for a child, a teenager, and an adult are RM10, RM18, and RM25 respectively. For discussion, from the results above, it is clear that using the quotient elimination method to solve the system of linear equation is effective for determining the entrance fees for the children, teenagers, and adults. We denoted the variables x, y, and z as children, teenagers, and adults, respectively, to be used in the quotient elimination method. And then after that, we write down the linear equations and convert them into form of augmented matrix. Lastly, we complete our solution by performing elementary row operations on the augmented matrix until the row echelon with the final answers x equals to 10, y equals to 18, and z equals to 25. Thus, these values are reasonable and aligned with the total fees paid by each group. For result for question 2, the last methodology answer for question 2 says that x equals to 7, y equals to 12, and z equals to 6. As a result, the fares for each transport, which are bus, taxi, and van, provided by the transport company for an individual are RM7, RM12, and RM6 respectively. So, next for the discussion. The previous results show that it is effective to solve the system of linear equations using the Gauss-Jordan elimination method in order to determine the individual transportation fares. We denoted the variables x, y, and z to be used in the Gauss-Jordan elimination method, and then after that we write down the linear equations and convert them into the form of an augmented matrix. And lastly, we complete our solution by performing the elementary reduced row operations on the augmented matrix until we get the final answer for x equals to 7, and y equals to 12, and z equals to 6. This completes our solution, and as a result, it is aligned to the overall amount that each group, each type of transportation charge an individual.
Now, and discussion for question 3. As a result, the price for each confectionery, which are curry puff, donut, and nugget, are M0.5, 0.6, and 0.4 respectively. The discussion, the results show that the system of linear equation using the inverse matrix method in order to determine the price of each confectionery. The variable x, y, and z for curry puff, donut, and nugget respectively to be used in the inverse matrix method. Then, write the given system in the form of ax equal to b, and the solution will be in form of x equal to a inverse b. Lastly, we will get the final answer, which are x equal to 0.5, y equal to 0.6, and z equal to 0.4.